Hi everyone. This is the video in case you missed or you want to review Note C, and we are still working towards checkpoint number 1. So this first slide, I'm going to show you the objective that you can type in the first box, and then I'm going to give you 2 rules, one for linear, one for exponential. So the objective for this set of notes is right here. So it's this yellow sentence. You can pause the video and go ahead and type this objective in that first box. The objective says I can create linear and exponential functions given a real world situation. So notice for this set of notes, we are just focusing on linear and exponential, and a real world situation is just a word problem. So I'm going to give you a word problem, and then you're going to create either a linear or exponential equation. Okay, so go ahead and type that in that first box. Now, your next box on your notes is one box for linear and one box for exponential. We're going to have some rules. So next, you can go ahead and pause on this slide and type out these 2 rules. Again, the first one is for linear and the second one is for exponential. So when you read a word problem, you have to figure out, is that word problem a linear situation or is it an exponential situation? So for it to be linear, the word problem is going to have a constant rate. That word constant means the same thing. It's constant. It could be going up or down. So it could be, again, going up. It could be going down. That does not matter, but it has to be by the same amount. So for example, I give you $1 every day. That would be linear because it's the same amount. Or maybe that would be going up, right? That'd be $1 every day. Or maybe I'm taking $1 away from you. You're paying me $1 every day. So it could be up or down, but again, the same amount, $1. Okay? And again, that's a linear word problem versus an exponential word problem is either multiplying or dividing. So what you're going to look for an exponential word problem are these keywords: doubling or tripling, right? That means I'm multiplying. If I'm doubling, I'm multiplying by 2. If I'm tripling, I'm multiplying by 3. You're going to look for percents. Percents are also exponential. Or maybe words like this: I'm taking a half of what you have, or a fourth. That would be dividing. I'm taking half of your money or a fourth of your money. You're cutting it down. You're dividing. So here are 2 rules. Again, make sure you have both of these rules written in your notes, okay? And then we are going to go to our first example. So we're going to work on slide number 2, and we're going to create equations that fit these word problems. So let's look at example 1. Jamarcus has $50 in his savings account. Every month, he adds $20 to his savings account. So you have to ask yourself, does this word problem represent the linear situation or the exponential situation? Reminder, linear, same every time, right? The same thing is happening every time. Exponential, we're looking for these keywords. So at first glance, I'm not seeing any of these keywords in this situation. I'm not seeing doubling or tripling. I'm not seeing cutting in half. So what I am seeing is that every month, right, it's the same thing. He's adding $20. $20 every month. $20 every month. So when it's the same, this is going to be linear. So I'm going to first start, actually, I'm going to type in this box that it's linear. Okay, so I know I'm telling myself what it is, but what I'm asking you to do is to make the equation that represents this situation. So if I go back, this is actually from our last set of notes. If we remember, here is the linear equation, right? Y equals mx plus b. So I'm going to start by typing that in my box, okay? But I don't want to leave it with all these letters. I actually want to change some of these letters to fit my problem. So let's go back to this little diagram, right? I know that the m represents the slope, or we're really going to call how something is changing, the rate of change. And the b represents my starting value. So let's look at this problem again. So the M has to be, how is it changing? Well, remember, every month he's adding $20, right? That's the changing. It's changing by 20 every month. So I'm going to erase the M and put 20. And then remember, the B is my starting value. Well, what did Jamarcus start with? He started with that $50. So the B is going to be 50. So actually, this equation matches this word problem. It has my starting value of 50 and my rate of change of 20. And also, I know it's linear. So that's our objective right there. We just did it. We identified what it was, linear. We made an equation. All right, let's keep going. Example 2. The deer population in Ohio in the year 1967 was 5,000. Every year, the deer population doubles in size. So I need to figure out, is it linear or is it exponential? Well, right away, I saw one of the keywords. Hopefully you saw it as I was reading. I saw that word doubling. So whenever I see that word doubling, I know that it has to be exponentials. So I'm going to start by saying exponential. Okay. Now let's go back to our equations. The exponential ones from, again, our last set of notes was y equals b times a with an x up high. So I'm going to type that out first, and then I'll change the letters. Y equals b times a. Now again, that x is up high. A little trick on your keyboard, if you push Control and then that period, or like the yeah, at the same time, Control period. Yeah, you can actually go up high and put the X up high. Or if you don't like that, you can always just do an up arrow and just tell me the X is up high. But I think it looks a little nicer. You Control period and put the X up high. Okay, let's change these letters to match our problem. So remember, the B is your starting value. Well, how many deer did we start with? We started with 5,000. So I'm going to change this B to be 5,000. And then the A, if we go back to our picture, the A represents the rate of change. How is the population changing? Well, it's saying every year the deer population doubles. I know that's not like a clear-cut number, but you have to ask yourself, when you're doubling, what are you multiplying by? What number are you multiplying by? Hopefully you know that when you're doubling, you're multiplying by 2. So that's my rate of change. So this is saying, starting with 5,000, doubling every year, multiplying by 2. So again, this equation matches this word problem. Okay, let's keep going. Example 3, you took out a $5,000 loan to buy a new car. Every month you make a $100 payment on the loan. Ask yourself again, linear, exponential. I'm seeing the same thing happening every time. You're making that $100 payment. You're not making 100 and then 1,000, then 10,000. No, it's 100. So it's going to be linear, same every time. My equation is y equals mx plus b. My b is my starting value, which my starting loan was 5,000. So I'm going to change that. Now, just be careful here. It's saying that you're making $100 in a payment. So if you think about it, when I'm paying $100, how much I owe should be going down, right? You shouldn't be making payments and it goes up. So just think about it as like your loan should be going down. So when something is going down, it's decreasing, it's going to mean that my rate of change is actually negative. So negative, I'm going to highlight this so you can see what I'm talking about. It's negative 100 because you're making that payment of $100. So that's going to be a little trick in a checkpoint. If you're going down, it's got to show negative, okay? And that's our equation. Next, you have 20 shoes in your collection. You want to triple the size of your collection every year. There's one of our keywords, that word triple. So that means that we're doing an exponential. And my equation, again, this is all from our last set of notes, is y equals b times a with the x up high. To go up high again is Control period. B is my starting value. Well, we started with 20 shoes, so I'm going to change that B to a 20. And then A is my rate. I know that it's tripling. Tripling means you're multiplying by 3, just like triplets are 3, right? We're multiplying by 3. So this